Good morning, my class 8 student. Already we had started our force and pressure chapter, and we are on the mode of discussion. Few things, few examples which are daily life happening surrounded us, and which are for atmospheric pressure. So let's go for the next example. We know syringe, injection syringe, tetanus vaccine syringe. We know very well. So syringe filled with liquid. How? That is also due to atmospheric pressure. I am showing you by a simple diagram. Syringe looks like this. This is syringe. Clear? Here inside syringe you are having a rubber plunger, and this is a rubber plunger. So when you are pressing syringe from this side, air will get outside, get evacuated from the syringe, and if you are uh, pulling that syringe this side, air will come inside the syringe. This is the structure. So what is happening when we are filling that syringe with liquid? What is happening? First, what we are doing at the beginning when the pathologist was breaking the seal of the syringe, you can see the plunger of the syringe not here. Plunger of the syringe are exactly at the mouth of the syringe. Clear? Now he is doing what? He is pulling that plunger outside of the syringe. Means the plunger is pulling outside. Clear? And during that interval, the mouth of the syringe is keeping inside your blood vessel or in the vaccine tube. Clear? So when they are pulling that syringe, here no air is there. So if you are pulling that syringe, there is a vacuum place, means there is a decrease in pressure. Now, since there is vacuum, to fill that vacuum, that vaccine or that your blood is going inside that syringe, because that vaccine tube or your blood vessel has far more pressure with respect to the zero pressure which is here. So to diminish, equalize that pressure, the blood from your vessel or the tetanus vaccine from the container is filling that syringe. That's how the syringe works. Now I am going for the rubber sucker. Rubber sucker are used to hook in the kitchen or bathroom. We know what is rubber sucker. Rubber sucker is just like this kind of things, spherical things. Here you are having a knob like this. You are pressing that rubber sucker, keeping on the wall, leaving it, so it will stick on the wall. How does it happen? So if I draw the rubber sucker, I am showing the internal diagram. Rubber sucker looks like this. Here you are having that hook. This side is completely vacuum. Now if you press the rubber sucker, so what is happening? Whatever the air inside the rubber sucker will decreases or eliminating from inside the sucker. Now you are leaving your hand. Now if you leave the hand, since it is a elastic material, it want to keep its shape intact, so it will remain its original shape. Means inside the rubber sucker there is still vacuum, but outside there is air. That air is giving from every side the atmospheric pressure, huge atmospheric pressure, and due to that huge atmospheric pressure, still inside vacuum, the air sucker remains keep very tightly on the wall. Clear? So that's why whenever you are purchasing next time rubber sucker, be sure that it is completely non porous, means there is no single hole remains on the rubber sucker, because if there is hole, what is happening? Through the hole, air is going outside and rubber sucker will loosen up and fall from the wall. So that is about rubber sucker. Next coming, it is difficult to take oil out from a sealed tin if only one hole is made in it. You know, whenever there is an occasion or something, we are purchasing huge quantity of oil, 5 liter, 6 liter, 10 liter. So if you are making a small hole on that tin and want to take oil outside, you can't do with a single small hole. You need a second hole also. Why? Because if you are making a small hole, suppose this is a container, oil container. Now bottom part you are making only single hole. So huge oil want to come from inside of the container to the outside, and since air also gets space from here, air also wants to go inside the container. Due to that equilibrium, just like glass and postcard, oil will not come outside. So you need a second hole or large hole. So what? Air will, there is a non-equilibrium condition and oil will come outside from the container. Now coming from the next one. Lizards are able to move on the wall and stay wherever they want to desire. We know lizard can move very well on the wall, just like Spider-Man. So how they were doing? Lizard have claws like this, and inside that claws they are having just like rubber sucker structure. So whenever they want to move on the wall, they are keeping their leg like this and they continuously pressing that feet. So when they are pressing that feet, so inside that clause, air is coming outside, clear? So air is coming outside means there is vacuum. Now since atmosphere does not want to keep any space vacuum, so on that claw, air is giving a pressure, or whole atmosphere is giving pressure. So by that, everyone's lizard can easily move on the wall. Clear? It is written also here. This is because their feet behave just like suction pad, so they remain pressed against the wall and due to atmospheric pressure. Next one, the astronaut and mountaineers have to wear special type of suit to protect themselves from the adverse effect of low pressure prevailing at the great heights. As I am telling, as we are increasing height, now, as I am telling that air pressure decreases with increase of altitude. Now you know we are having a specific blood pressure. So blood pressure will not change if I am moving towards the high altitude or I am moving through space. So since blood pressure of our blood vessel will not change, suppose there is outside pressure slowly decreasing. So if outside pressure slowly decreasing and your blood pressure